Well, I'd like to make one quick point, Ogre. Just one quick.
Okay, sorry.
No, that's okay. It'll be quick. One thing that comes to mind on that one, John, is, and I agree with what you're saying there, especially in debates. Dr. Dan, for example, we're discussing ERVs and other classes of retrotransposons, and he goes into the minutia and says, "Oh, you're wrong. ERVs are not a subclass of retrotransposons." Just kind of wasting time on such a minute detail, when in fact you can find paper after paper, source after source that directly states ERVs really are a subclass of retrotransposons. And then I show that to him and he says, well, yeah, some people think that, but there's debate among scientists. But my whole point is something like that is just a complete waste of time. It's avoiding the actual key issues, the bigger picture. And I do find that a lot debating evolution. I'm not saying you're like that, Ogre, but I've personally encountered that many times.
So I feel you guys, believe me, I do. When I watch debates and on other channels as well, it always gets drugs in the mud. No one likes that. 100% agree with you. The reason I brought up the bison question to Neph was because it was about the genetic bottleneck, right? And the argument that David was making is if the population gets too small, it can't grow again without genetic problems, right?
Yeah, well, that was part of my issue. And if you have all the everything, all of life, bringing down to 2 or 7 individuals, they'll go extinct pretty quickly. I mean, the problem is you're not going to get the hyper rapid evolution that the blood model is going to require. If you're going to need to get all the extant biodiversity within a couple hundred to 1,000 years maximum after the flood. You simply can't do that if everything was reduced down to only 2 individuals. You would end up having to create like several dozen new species each day to create the extant biodiversity that is represented in Earth just very shortly after the flood.
Yeah. And I guess, I mean, this isn't my field, right? I deal with rocks. Living things suck. I hate them. I never studied them. But I'm sure there's a number that a population can get down to where there isn't a problem where it is, right? I think cheetahs have that issue where the cheetah population got so low that they have these issues with defects, right?
Yeah, that's
what's funny about that is your cheetahs right now are down to, like, the last time I checked, they're down to about 7,000. They're highly degenerate. Conservationists are incredibly worried about them. They were at 10,000 at one point, but they're incredibly close genetically due to inbreeding, due to a severe bottleneck. And I always bring it around to, because oftentimes the critics, they will say that biblical creationists have a bottleneck problem, when in fact your very own out of Africa scenario, which suggests that there was a population bottleneck of between 2 and 10,000, not for one generation, not for 2 generations, but for thousands of years. We know that would result in the fixation of many, many deleterious mutations that have accumulated for millions of years. You got the Australopithecines evolving into Homo erectus into Homo sapiens, and then you got the bottleneck. So how, according to your model, can we believe, why would we believe that extremely genetically compromised population of, say, 2 to 10,000 that would have been so highly inbred, how did they suddenly explode into all parts of the world, seizing dominion over the planet like the out of Africa scenario would suggest? So my point is, it seems like the evolutionary story is the one with the inbreeding problem.
So let me point out something real quick before he answers that. I pasted in the side chat the source that I used for my discussion about bison. It comes from it was off of Wikipedia, citation in Wikipedia, which states in North America in the early 20th century there was less than 100 bison living on the continent. So I just point that out.
Yeah, I saw that. Thanks, Neff.
Yeah, and I found another paper from like the intertribal bison something or other. They said it got down to 200, like below 250 was another one I found.
Yeah, the numbers are probably going to vary. I think if you study evolution theory, you'll find the genetic diversity of creatures that live in this world, you find that it's genetic diversity is going down. Everything on this planet is moving towards extinction because of the accruing mutations, especially single nucleotide variants that are affecting protein codes and adding diseases left and right to human beings and everything else. We're all going extinct. That's the opposite of evolution.
Okay, so this is kind of like where I wanted to go in the after show, because I know Standing for Truth and I were kind of discussing that in the chats. Standing for Truth said that 300 generations is the maximum time frame before we wipe ourselves out naturally due to the accumulation of deleterious mutations, correct?
Well, I mean, if human beings have been experiencing random mutations for the time that the evolutionist believes humans have existed, just humans. I mean, we could apply the same reasoning to every creature that came before every creature in the evolutionary tree, the imagined tree. Then there simply would be no evolution. No organism can exist for tens of thousands of years, accruing mutations at the rate at which human beings do. It would simply rewrite our genomes with thymine, because the majority of mutations that the single nucleotide variants replace, when a replacement of a base nucleotide occurs, more often than not always, but more often than not, it's replaced with thymine. So over a period of 50 million years, a very large percentage of the human genome should have been turned into nothing but thymine instead of cytosine, guanine, and all the base pairs. We should have massive numbers of thymine in there, just corrupting the heck out of our genome and making us unsuitable for survival. So the evolutionist believes that mutation is this fantastic designer of unfathomable complexity and efficiency and function. But real science shows us mutations are destroyers. So evolutionism is pseudoscience in denial of what the actual scientific data shows.
Well, not only, and David, and Ogre can, and I know it's not your expertise, Ogre, but my question about the out of Africa scenario, because you and I, David, we discussed this in our debate a few days ago on the origin of genetic diversity. And as you know, evolution explains the origin of all DNA differences, all genetic diversity as the result of mutations over time. And then natural selection acts upon that variation. So here's the thing, by the time you reach that out of Africa event where you have that very significant population bottleneck, mutations have been accumulating for millions and millions of years. And now, as we know, by definition, inbreeding exposes the hidden reservoir of genetic mistakes. Those mistakes that have been accumulating, they're in a recessive state, they're now manifested, and they lead to rapid and accelerated genetic degeneration. So, David, how do you explain how that's remotely even plausible in the out of Africa event because of the significant inbreeding? Can you answer that question, David?
But before David responds, Zach Brannigan, as usual, is an idiot, as you can see from his chats. Whoa, I just realized we were wrong all along. It's not the atheist worldview that's terrifying. It's the Christian one. We're all going extinct and dying because God got mad we ate an apple. Good night.
Yeah, good night, Zach.
Well, Zach, as usual, your dumbass seems incapable of comprehending the premise that you have an immortal soul that can live for eternity and not have to worry about going extinct. So I don't really know what's terrifying about the premise of immortality and not being bound by the limitations of the current version of the mortal coil. That to me doesn't actually seem all that terrifying. It's actually kind of cool. It's just a matter of actually opening your mind to the bigger picture and not being so myopic in your worldview. Now,
well, he could get the gift of eternal life from Christ if he wished it, but he doesn't want to live forever.
Yeah, now, David, sorry for my little diatribe there. Go ahead and respond to SFT's question.
Can you repeat the question again? I'm sorry, I'm kind of turning the phone.
Well, I gotta say, I think I repeated it twice. It's
David, your connection.
It's the same question. Hey, David, I asked you that question, I think, in every one of our previous 4 debates. So here, I'll make it quick. How is the out of Africa population bottleneck even remotely plausible due to all the enormous amounts of deleterious mutations that have been accumulating? They are now manifested. And as we know, the out of Africa population bottleneck wasn't 1 generation, wasn't 2 generations. It's hard to find a number, but it's at least more than 1,000 years in order to reduce levels of heterozygosity, because they invented that hypothetical out of Africa population bottleneck. Why? Because when they discovered that humans have incredibly low genetic diversity, they were shocked. They did not predict this. Therefore, they hypothesized that there must have been an incredible bottleneck in the past that would have reduced genetic diversity, but that would have resulted in incredible genetic damage. So how is that out of Africa scenario even remotely plausible? David, go ahead.
Okay, yeah, this is something that I'm going to be working a video on, because this is something I'm
Well, Dave, you got to speak up. I can't hear you.
Okay, is this any better?
A little bit.
Yeah, so I hate to, I'm not deflecting or anything, but I am going to make a video about that. It is 12:45-ish almost, so I'm starting to kind of doze off. And
well, David, instead of making a video on it, can you just see? Here's the problem. We're looking at the cheetahs today, and we know what bottlenecks do. Okay, and here's the thing. I debated a biologist on it, and he was kind of thrown off as well. So I don't know if you could have a better answer than a biologist, but we know by definition, inbreeding is not a good thing. And the more deleterious the mutations are based on how functional our genome is, if the majority of mutations are deleterious, that means those 100 new mutations per person per generation that are accumulating are degenerating our biological information systems a lot faster than we ever thought. Therefore, David, if those nearly neutral mutations are invisible to natural selection, we know natural selection acts upon the best beneficial mutations, gets rid of the worst detrimental mutations. But my question to you is, what type of selection can you provide us with tonight that can remove so many slightly deleterious mutations that are pouring into our genomes generation after generation, David?
So are you talking about like the mutations like the sickle cell anemia that have like a double-edged swords where it can be beneficial but not beneficial as well? Is that what you're kind of going at?
No, he's asking you what genetic mechanism saves us from the mutation rate.
Well, of course, natural selection is what would it?
Well, that's what he's asking. How is that to work?
Yeah. Because I'm telling you, I'm pointing out that everybody agrees natural selection keeps a species as strong as it can be. It's a fine-tuning mechanism. Natural selection, better understood as differential reproduction, who's reproducing the most. Natural selection will remove the worst deleterious mutations, okay? It can see that. And it will amplify once in a while a beneficial mutation that is context, environmentally dependent. Oftentimes they're reductive. For example, like sickle cell anemia, yeah, it's got a significant benefit, significant impact, but it's due to a broken cell, broken protein, broken gene. It's reductive, not taking things forward. So the question is, those slightly deleterious mutations that are kind of like a single spelling mistake in a book the size of an encyclopedia. You can't see each one. Each one on its own is inconsequential, but it's the buildup of them over time that degrade the book, the message in the book, and in biological information systems degrades us slowly, like rust on a car. So what type of mechanism, David, can you provide us with tonight that can get rid of these mutations that are deleterious pouring into our genome?
Again, I'm not quite sure off the top of my head. Again, I am going to bed pretty soon.
The important point, the really truly important point that Standing for Truth is making is that natural selection can't see anything except the worst mutations, the most destructive. It does not see the vast majority of mutations. They're invisible to natural selection. Reproduction passes on mutants, entire mutants with all their mutations. The only ones that are going to become so unfit to survive are those that receive a mutation that makes them so degenerate that they won't be selected by for breeding because the mates won't accept them, or they just are so ridden with disease that they don't survive. So natural selection can't see the vast majority of mutations.
So I got a question on this topic, if you don't mind.
Yeah.
This is not my area, David. If I start going off track, let me know. Right, I play with rocks, but Neff, you seem to be talking about mutations as in like the big ones, like I'm born with 3 feet and none of them works on a mutation.
No, I mean all kinds of diseases.
Well, but you said mutations, it gets rid of the bad ones. I'm
Right.
just quoting you here.
Well, the worst.
Aren't mutation something that like technically a mutation is just any particular change over time, right?
Right. So what is the effect of?
Is the argument you're making that with the genetic bottleneck as standing? Is the argument you're making that we eat those little teeny mutations with twofold of those? Is that what's going on here? Or
yeah, because the majority of mutations are nearly neutral. The beneficial mutations, according to Lenski's experiment, they're incredibly rare, about 1 in a million. Sure. And then the incredibly detrimental ones, we've kind of removed natural selection as a human population. We take care of the sick. But in the wild, if an animal is born with an incredible defect, it will die. Natural selection will remove it from the population. It's not going to reproduce, right?
Or breeding selection. It won't be selected as a mate because the other members of the population will see it as defunct and they'll reject it.
Oh, good night.
Yeah, take your time, Ogre. We've been talking a lot. I was just trying to get an answer to David, but he's tired, and that's fine.
Yeah, so, I mean, I'm just trying.
The floor is yours.
I'll do the best I can here, completely off my basis, but I'm trying to get. I want an understanding of your point. That way, I can think about it correctly. Right? Strong manly, I think it's called. So that's what I'm trying to ask. That's why I'm trying to ask you these questions. So, standing, the argument for the bottleneck issue is the humans, when they left Africa, accrued so many negative mutations, teeny ones, that they should have died off. What?
In Africa, they say Homo erectus. Well, according to the literature, there was 2 out of Africa. It's a subgroup of erectus left. They would have independently evolved into like Neanderthalensis, Heidelbergensis, Naledi, Floresiensis, out of Africa. Because the problem was when modern Homo sapiens left Africa, it was a big surprise that there were other people groups, other
They ran into them in like Europe and stuff. Yeah,
right. Yeah. So there were people groups outside of Africa, but the thing is, modern Homo sapiens evolved from erectus in Africa, but they didn't leave Africa until they experienced a severe population bottleneck that would have decreased levels of genetic diversity, because we know humans today are 99.99% similar. So therefore, the scientists, they look to this population bottleneck to explain that. But here's the thing. It wasn't 1 or 2 generations. It was similar to the cheetahs. Therefore, that hypothetical population, some say 2,000.
Okay, I get the connection you're going. So we know cheetahs, we know bison, to throw it back, have these problems in their genetic code. Why don't humans have that same problem? Is that the statement?
Well, no, it's in the out of Africa event, that population of 2 to 10,000 would have been so genetically compromised, comparable to the cheetahs we see today.
Yes.
Therefore, this is what the evolutionists say we came from, the out of Africa scenario. We came from Africa, but that population would have been so genetically compromised. There's no feasible way that they could have suddenly exploded into all parts of the world, seizing dominion over the planet, because they would have assimilated So in your opinion, or, how is that plausible given how genetically damaging that bottleneck would have been? Go ahead.
All right. So again, no expert, right? But I would have to make the assumption. You know what? I'm not even going to try here. I play with rocks. I don't know. I know all these processes. I can't even take a go at it. Sorry.
No, it's definitely something worth looking at. I've debated, you can see some pretty in-depth discussions with some biologists I've had on this one. It is an issue. Well, and that's the thing, even with the one Y chromosomal line, the one mitochondrial DNA line, we know mitochondrial DNA has incredibly low variation worldwide. The Y chromosome, same thing, which demonstrates that our genome is young. But the evolutionists, of course, they don't conclude that we are young as a population. They have looked to this population bottleneck to reduce levels of genetic diversity. And as a result, now we are stuck with one Y chromosomal line, one mitochondrial DNA line. But what's funny is this is exactly what the Bible would predict. One Y chromosomal ancestor, one mitochondrial DNA ancestor, low genetic diversity. So we don't have to invent fancy stories. This is exactly what we'd expect.
Right. The genetic data actually supports the biblical account.
So, don't mind. I know your history.